Hello everyone, this is the third and the last page of the lesson. So we'll talk about conjectures and counterexamples with triangles. So what is a conjecture? Well, first of all, it's a fancy word, but it means nothing but a conclusion. It's a conclusion that is drawn from a number of individual facts when it comes to solving math problems. Now, this conclusion may or may not be true. So in order to prove that the conclusion that we are drawing based on what we see is true or not, we often build counterexamples. Counterexamples are used to disprove a conjecture. I'd rather explain it to you both these terms through an example. So in this example, we have Costa who measured the right triangle. So we're given that this is a right angle triangle. And he noticed that the median bisects the right angle. So this would be the median. And he conjectures, or he draws the conclusion, that a median then must bisect the right angle in all right angle triangles. Is the conjecture correct or not? So first, let's do a little bit of work with our triangle. Here we're going to call this the triangle ABC. And we're going to say that we're given that I'll call this M. CM is the median of this triangle. And the median of this triangle will divide the side AB into two equal parts, you see? And we are told that in this specific triangle, the angles that are formed here, at the right angle here, right, are equal to each other. They're each 45 degrees. So now we're thinking, okay, so does that happen in all right angle triangles? So the conjecture is a median will bisect the right angle in all right angle triangles. That's the conjecture. Okay, and we don't know if this is true or not, but we have to prove it. So we're going to build a counterexample. And here is another right angle triangle that I'm going to draw. I will find the midpoint of the hypotenuse. I'm just eyeballing it for now. And I will connect it to the vertex where the angle is 90. And now I will try to compare the two angles created at the right angle by this median. So we have this angle here, and then we have this angle here. Now, just by looking at it, do you think that these two angles are equal to each other? And it doesn't look to me that these two angles are equal to each other, so maybe the conjecture was not correct. But how do we, this is called building a counterexample. Okay, so a counterexample is taking your idea of drawing a median into a right angle triangle at the right angle into a different right angle triangle that is slightly different shaped, differently shaped, so that you can see whether or not that applies in triangles other than the one that we were given. Okay, now if for the proof enthusiasts, people that want to actually see the proof to it, not just a counterexample, then we're going to say, well, in this case, we are given that CM is the median. So we are given that AM equals MB. Okay, and we need to prove that, and also we know that the angle, why not use this triangle here? So it's better to connect it with a diagram. So I'll call this the angle C, I'll call this A, and I'll call this one B. And we're going to say that CM is the median, so these two sides are equal to each other. And we also know that angle BCA is 90 degrees. And that's given. So we need to find or prove that the angle ACM equals the angle MCB. Okay, so let's check and see. For these two angles to be equal, then we need the two triangles to be equal to each other. If MCA equals MCB, then the triangle MCA must be congruent to triangle MCB. Well, is that true? Well, to start with, they do have a common side. They need to fulfill three conditions, right? So they have CM a common side. And they also have two sides that are equal to each other. So BM equals AM. Okay, because CM is a median. So we're going to say, okay, perfect. So what we are going to do then is find 1/3 thing that they have equal, and then we'll be done. Do you think you can find anything else that is equal? Remember, you cannot use these two. We have to prove that these two are equal. Are these two angles necessarily equal? No. If these two angles were equal, then yes, these two would have been equal, right? So just like we were in this triangle here, which should have been an isosceles, probably, because these two angles would have been equal. So we're going to say, well, there is no third condition. So condition 1, condition 2, condition 3, we have none. So we're going to say that the two triangles are not equal, and that means that the two angles are not equal as well. So we're going to say that the conjecture was incorrect. Okay, and that's the lesson for today. Hope you enjoy your doing